Describing data. In this video, we'll cover ways to describe the details of your data. Documentation is worth creating while you're processing data and worth maintaining throughout your research. It will help you recall your work and explain it to others as you get into the messy details of research. Using codes. In another video, we mentioned using validation to ensure that the values entered in your data are correct and consistent. We also discussed using codes to substitute for missing values. Codes can be used more broadly than just for missing values. They can also represent other values. For example, numeric codes are often used for categorical variables. Like in a study of tobacco use, 0 may be used for none, 1 for smoker, 2 for chewer, and 9 for missing value. These are called dummy codes because they have no arithmetic meaning. It doesn't make sense to add or find the average of them. An average of 2.167 doesn't mean anything for a categorical variable like tobacco use. However, simple codes can make it easier to enter data without spelling errors or other mistakes. When entering values in your data, consistency is important. Misspellings, differences in capitalization, or different wording can affect later analysis. Importantly, codes need to be used consistently. In this case, 0 should always represent none. Since the meaning of a numeric code for a variable like tobacco use isn't immediately obvious, the decision also needs to be documented. In another video, we mentioned making sure to document what your codes mean. Documentation is valuable to create and maintain throughout your research, because it will help you to recall your work and explain it to others. Let's see how to describe your data using two similar tools, data dictionaries and codebooks. Data dictionaries are a way to write out a detailed description of the data at the level of each variable within a dataset. Codebooks are often more detailed than data dictionaries. They are commonly used in social sciences and contain the list of codes used in research. A well-documented codebook also contains information intended to be complete and self-explanatory for each variable in a particular data file. First, we'll consider data dictionaries. Data dictionaries are usually saved in a separate text file from the data. Let's look at and try to interpret a data file from a different discipline. The data you see here are from the Duke Lemur Center, where researchers study lemurs. These data are clean and well formatted, but they can still be difficult to interpret. Zooming in on a portion of the dataset, we see that variable naming can get complicated. The column names used in this dataset aren't intuitive to someone faced with the data for the first time. Data dictionaries can help to explain what a variable like age@wt_mo_no_des means, how it was calculated, and what sort of values you can expect to occur within the column. Taking a closer look, the data dictionaries list variables one by one with an explanation for each. We see that age@wt_mo_no_des is the age in months for each lemur, with no decimal. It's the age@wt_mo value rounded down to a whole number for use in computing average individual weights of lemurs. The data dictionary explains what each variable name stands for, and in this case, that the column containing the variable was calculated from another column in the dataset and should only contain whole numbers. Codebooks contain much of the same information as data dictionaries, but are usually more informative. Like data dictionaries, codebooks are often saved separately from the data that they describe. The one we'll look at is saved as a PDF file. This time, we'll look directly at the codebook example without looking at the data file first. We're looking at the codebook that describes the Canadian Household Survey from 2011. Along with other information, the survey gathered data about the number of bedrooms in Canadian households. Focusing on a snippet of this codebook, we'll look at how it describes a single variable, the variable abbreviated bedRM. At the top, the full name of the variable is listed. bedRM stands for number of bedrooms. Next, the information section explains the type of values used for this variable. They are numeric, and their range is from 0 to 8. Basic summary statistics follow. The definition is a full description of what the variable measures, all rooms designed mainly for sleeping purposes. And now the information is more detailed. The universe describes the population being studied. And the notes section includes a data quality note that explains errors in the data. Finally, statistics are computed to show the frequency of different values. Without even looking at the data, we know that 3 bedrooms was the most frequent response in the survey. Although the codebook describes each variable and has much of the same information as the data dictionary, it is more detailed and lets users learn about the data without needing to inspect it. Unlike a data dictionary, it also includes information such as data quality notes and summary statistics for each variable. Describing data. Tips. When describing your own data, consider creating a data dictionary or a more detailed codebook. These tools will help you to keep track of your variables and their meaning. For each variable, document the name assigned to the variable, what the variable represents, or a definition, the format for the variable, is it text, numeric, and how many decimal places. For scale variables, include the units of measurement, such as degrees Celsius or US dollars. For categorical variables, if they are coded numerically, note the numeric codes and what they represent. Include missing value codes. Make a note of known issues with the data. These could be systematic errors or missing values. Finally, describe the relationship to other variables, like when a variable is derived from another variable in the data. This information will benefit you when working with your data and simplify your analyses. It is also important information for assessing a dataset. For example, you may decide to use reference data or reuse existing data for your research. Data dictionaries and codebooks will help you to judge the usefulness of these datasets for your purposes and the quality of the data. In this video, we covered describing your data. If you want to learn more about good research data practices, check out our other data management videos in this series.